Now we are going to continue the examples in the exercise 4.2. Okay, here example number 8. Evaluate integral 0 to pi by 4 under root of 1 plus sin 2x dx. Under root of 1 plus sin 2x dx. Now here integral 0 to pi by 4 under root of 1 plus sin 2x dx. Okay. Now here we use the trigonometric formula, that is the 1 plus sin theta. 1 plus sin theta is equal to, it is cos theta by 2 plus sin theta by 2 whole square. 1 plus sin theta, it is cos theta by 2 plus sin theta by 2 whole square. If it is a 1 minus sin theta, then it is cos theta by 2 minus sin theta by 2 whole square. Here it is a 1 plus sin 2x, so we use 1 plus sin theta. Here it is a theta and it is a theta by 2. Now here it is a 2x, therefore in the formula we use angle x. Okay. Now the formula for this, integral 0 to pi by 4 under root of cos x plus sin x whole square dx. Now integral 0 to pi by 4 cos x plus sin x dx. Okay, square and this under root. Now both are the standard integral, so we can direct integrate. Cos x, the integral of cos x, it is a sin x, plus integral of sin x, it is a minus cos x, and limit 0 to pi by 4. Okay, now it is an integral and it is a limit 0 to pi by 4. So first we put the upper limit minus then lower limit. Okay, in this integral we put upper limit, that means x replaced by the pi by 4. Then sin pi by 4 minus cos pi by 4 minus sin 0 minus cos 0. Okay. Now we calculate this. Sin pi by 4, sin pi by 4, it is 1 by root 2. See carefully this. Sin pi by 4, it is a 1 by root 2 minus cos pi by 4, again it is 1 by root 2. Okay, and here minus sin 0, it is a 0, and minus minus plus cos 0, it is 1. Plus 1 by root 2 minus 1 by root 2 get cancelled, 0, and it is 1. Therefore the last answer, it is 1. That means the calculation of this, it is 1. Okay. Now we see the next example. Next example number 9. Integral 0 to pi by 4 sin to the power 4x dx. Now here I is equal to integral 0 to pi by 4 sin to the power 4x dx. See carefully. Now here it is a sin to the power 4, and we know that how to find the integral of sin square x, cos square x, tan square x, and cot square x. Here we know the integral of sin square x by using the formula for the sin square x, that is 1 minus cos 2x upon 2. Okay, but here it is a sin to the power 4. So this sin to the power 4 we can write integral 0 to pi by 4 and sine to the power 4 we can write in the form of sine square x whole square. Okay, and now integral 0 to pi by 4 sine square x, it is a 1 minus cos 2x upon 2 whole square. Here sin square x 1 minus cos 2x upon 2. Now again we can find the square of this term. Here 1 minus 2 cos 2x plus cos square 2x and whole to the upon 4. Okay, it is a square of this term. Now here it is a 1, it is 4 constant, we take the outside the integral, it is a 1, 2 cos 2x, again here it is a cos square x. Again for the finding the integral of cos square x, we use the formula for the cos square x like sin square x. It is sin square x is equal to 1 minus cos 2x upon 2, but here cos square 2x, so formula is 1 plus cos 4x, here it is a 2x, here it is x, we can write 2x, it is 2x, then in the formula we can write 4x. Then integral 0 to pi by 4, see carefully, it is 1 minus 2 cos 2x plus 1 plus cos 4x upon 2, it is cos square 2x and whole to the upon 4 dx. Now we can take the addition of this term, integral 0 to pi by 4, here 2 into this 2, this 1, it is 2 minus 4 cos 2x plus 1 plus cos 4x. See carefully this. This 2 we multiply this both term, therefore it is 2 and it is 4. This is as it is and whole to the upon 2 and upon 4. So we can write directly in the upon 8. Here it is 8 and it is dx. Okay, see carefully. Now first we calculate and then integrate. 0 to pi by 4. Here 8 we can write the outside the integral. Okay. Here it is 1 by 8 into, now it is a 2 plus 1, it is a 3 minus 4 cos 2x and it is plus cos 4x minus 4 cos 2x and plus cos 4x dx. Now we integrate this. Here it is a 1 by 8 as it is into integration 3, it is a 3x minus 4 cos 2x, 1 minute, the integral of cos 2x, it is a sine 2x upon 2 plus integral of cos 4x, it is sine 4x upon 4 and limit 0 to pi by 4. Now it is an integral. In this integral we put first upper limit and then minus lower limit. Then it is a 1 by 8. See carefully this. First we put the upper limit it is a pi by 4, therefore 3 into pi by 4 minus this 2 get cancelled, so here 2 sine, it is pi by 4, so we can write here pi by 2. Okay, 2 into pi by 4, here we can write pi by 2. Okay, see carefully, x replaced by pi by 4. When we write here pi by 4, it is a 2 into pi by 4 and 2 into pi by 4, it is pi by 2 plus it is 1 by 4, this 4, and when we put the x is equal to pi by 4, here pi by 4 and it is 4, we can write sine pi. Okay, here we put only the upper limit, that means x is equal to pi by 4. Here x is equal to pi by 4. Here we put x is equal to pi by 4. Then 2 into pi by 4, it is pi by 2. 4 into pi by 4, it is pi. Now put the lower limit, that is a minus 3 into 0, it is a 0. Minus 4 by 2, it is a 2 into sine 0. And plus 1 by 4 into sine 0. Okay. And now here it is a 1 by 8. See carefully the calculation. It is a 3 pi by 4. 3 pi by 4 minus sine pi by 2. Sine pi by 2, it is 1. So here we can write minus 2 only. Then sine pi. See carefully. It is a sine pi. It is a 0. Okay. Sine pi, it is a 0. So it is a 0. Now again here. Minus 0. Sine 0, it is a 0. Okay. Here it is plus and minus. Sine 0, 0. Then the last answer. Here it is a 1 by 8 into 3 pi by 4 minus 2. It is the last answer. 3 pi by 4 minus 2. If we multiply by 8, we get the calculation is, but it is sufficient. 1 by 8 into 3 pi by 4 minus 2. Okay. See carefully. First we use the formula for the sine square. Then again it is a cos square 2x. Then again we use the formula for the cos square x. And then it is upper limit minus lower limit. We get this answer. 1 by 8, 3 pi by 4 minus 2. Okay. Then check the calculation. Now next. Example number 10. Integral minus 4 to 2 1 upon x square plus 4x plus 13 dx. Okay. Now here again it is a 1 by quadratic function. So this integral we can find by using the completing square method. Integral minus 4 to 2 1 upon x square plus 4x plus 13 with respect to x. Minus 4 to 2 1 upon x square plus 4x, the coefficient of x, it is a 4, half of 4 it is a 2, and square of half it is again 4, therefore it is a plus 4 minus 4 plus 13. Then integral minus 4 to 2 1 upon, first three terms are the complete square, that is x plus 2 whole square. And here minus 4 plus 13, it is plus 9. So we can directly write it as a plus 3 square dx. Okay. Minus 4 plus 13, it is a 9. It is a plus 9 plus, and it is a 3 square. Now here it is a 1 upon x square minus a square. It is a special integral, 1 upon x square minus a square. Integral it is 1 by a tan inverse x by a. Then here 1 by a tan inverse of x by a. Okay, and here limit is minus 4 to 2. Okay, here this 1 by 3 we can take the outside the limit constant. Okay, here we can take a bracket here or here. Okay, here 3 can outside the this function because it is a constant. Now we put first the upper limit and then lower limit. Then tan inverse of 2 plus 2 upon 3, it is upper limit, minus tan inverse of minus 4 plus 2 upon 3. Here it is upper limit minus lower limit, and then it is 1 by 3 tan inverse of 4 by 3, it is 4 by 3, and minus tan inverse of minus 2 by 3. Okay, here 1 by 3 into tan inverse of 4 by 3, and it is minus tan inverse of minus 2 by 3. Here it is a tan inverse of minus 2 by 3. Here we use the properties of the inverse trigonometric function. Tan inverse of minus x is equal to minus tan inverse x. Okay, therefore the last answer, it is integral is equal to 1 by 3 tan inverse of 4 by 3 plus tan inverse of 2 by 3. Okay, here it is plus. Here we use the tan inverse minus x is equal to minus tan inverse x. Tan inverse of minus x is equal to minus tan inverse x. It is a property of the inverse trigonometric function. Now the last answer, it is 1 by 3 tan inverse of 4 by 3 plus tan inverse of 2 by 3. It is the last answer, and it is sufficient for the board exam. Okay, but if this answer is not in our option, okay, in the objective question, okay, in CET or JEE, if this answer not in our option, then again we use a property of the inverse trigonometric function. Here we use tan inverse x plus tan inverse y, and then calculate. Okay, here it is sufficient for the board exam, but we know that again the tan inverse, the property of the tan inverse x plus tan inverse y is equal to tan inverse of x plus y upon 1 minus xy. It is a property of the tan inverse. It is tan inverse x and it is tan inverse y. Now, so the answer of the integral is, it is 1 by 3 tan inverse of 4 by 3 plus 2 by 3 upon 1 minus 4 by 3 into 2 by 3, and then calculate it. Okay, therefore it is a 1 by 3 tan inverse. Okay, here we use this property, tan inverse x plus tan inverse y. It is tan inverse of x plus y upon 1 minus xy. Then calculate. Here it is a 4 plus 2 6 upon 3. Okay, in the numerator there is a 6 upon 3, that means 2. Okay, in the numerator there is a 2, and here 8 upon 9, see carefully, it is 8 upon 9, then 9 into 1, therefore 9 minus 8 upon 3, sorry, it is upon 9. And now the calculation, it is 1 by 3 tan inverse, here it is a 2 upon, it is 1 by 9. Okay, and that means the last answer, 1 by 3 tan inverse of this 9, the numerator, it is 18. Tan inverse of 1 by 3 into tan inverse of 18. Here it is a 2, and it is 9 minus 8, that means 1 upon 9. It is 1 by 9, and then it is. Okay. This answer is sufficient for the board exam. If in the objective this is not in our option, then again calculate. We use the properties of inverse trigonometric function, and then after calculation it is 1 by 3 tan inverse of 18. It is the last answer. Okay, it is sufficient for the board. Okay, now we see the next. Example number 11. Integral 0 to 4 1 upon under root 4x minus x square dx. Now integral is integral 0 to 4 1 upon under root 4x minus x square. Yeah, this integral is in the type of the 1 upon under root quadratic function. Okay, 1 upon under root quadratic function. Again, same procedure, completing square method. Integral 1 to 4. Now, this is a minus x square. Okay, so here the coefficient of x, it is a 4. Half of 4, it is a 2. So, we can write it as plus 4 minus 4, then plus 4x, and it is a minus x square dx. Then integral 0 to 4 1 upon under root. See carefully this. It is a 4. Take a minus common of the last 3 terms. Then it is x square minus 4x and plus 4 dx. This 4 as it is, we take common minus in the last 3 terms. 0 to 4 that it is a 2 square minus x minus 2 whole square dx. And now here 1 upon under root a square minus x square. 1 upon under root quadratic function, again special integral. 1 upon under root a square minus x square, it is sine inverse x by a. Then sine inverse of x upon a, and here limit is 0 to 4. Now first we put the upper limit and then lower limit. We can write here sine of 4 minus 2 upon 2 is sine inverse minus sine inverse of lower limit 0 minus 2 upon 2. Okay, here it is upper limit and it is lower limit. Sine inverse of this, x replaced by first 4 and then 0. Here it is upper limit minus lower limit. Now sine inverse of, it is a 4 minus 2, 2 by 2, 1, sine inverse of 1 minus sine inverse of minus 2 upon 2, it is minus 1. Again we here use the property of inverse trigonometric function. Here it is a sine inverse of 1 and plus sine inverse of 1. Okay, here we use sine inverse of minus x is equal to minus sine inverse x. Okay, it is a property of inverse trigonometric function. And then sine inverse of 1, sine inverse of 1, 2 into sine inverse of 1, and then it is 2 into pi by 2, and then last answer it is a pi. Sine inverse of 1, it is a pi by 2, 2 into pi by 2, last answer it is a pi. See carefully, check the calculation. Now we see next example. Example number 12. Again same under root quadratic function. Integral 0 to 1 1 upon under root 3 plus 2x minus x square dx. Again it is 1 upon under root quadratic function. Same procedure, by completing square method we can solve this integral. Integral 0 to 1. Okay, here it is a 0 to 1 limit. Now here the coefficient of x, it is a 2, half of 2, it is 1, and square of 1, it is 1. Therefore, it is a 3 plus 1 minus 1 plus 2x minus x square dx. Integral 0 to 1 upon under root. It is a 4. Take minus common of the last 3 terms. It is a plus x square minus 2x and plus 1. Zero to 1 upon under root here 2 square minus x minus 1 square dx. Again same formula, 1 upon under root a square minus x square, that is a sine inverse x by a. Then the integral is sine inverse of x upon a and limit 0 to 1. Then first put the upper limit, sine inverse of 1 minus 1 upon 2 minus sine inverse of 0 minus 1 upon 2. Then it is sine inverse of 0 minus sine inverse of minus 1 by 2. Again here we use the property sine inverse of minus x is equal to minus sine inverse x. So we can write here sine inverse of 0 plus sine inverse of 1 by 2. Okay, sine inverse of minus x is equal to minus sine inverse x. Okay, minus sine inverse x, and here already minus, so you can write here plus. Sine inverse of 0, it is a 0, and plus sine inverse of 1 by 2, it is pi by 6. Sine inverse of 1 by 2, it is pi by 6, and then last answer it is pi by 6. Sine inverse of 1 by 2, sine inverse of 0, and it is pi by 6. Okay. Now next. Example number 13. Integral 0 to pi by 2 x into sin x dx. Integral 0 to pi by 2 x into sin x dx. Here x into sin x, that is the integration by parts, u into v. Okay, in the u into v there is a rule for the proper choice of the first function and the second function, that is a Lec, that is logarithmic first, then inverse, then algebraic, trigonometric and exponential. Here it is algebraic and it is trigonometric, so we can take as it is u into v. Okay, then we can write the formula for the u into v, u into integral of v minus integral of derivative of u into integral of v in dx. It is the only formula for the u into v, but here the limit 0 to pi by 2. Okay, here we can write here limit it is a 0 to pi by 2, and here 0 to pi by 2. Okay, here we can take the integral x into integral of this sin x, it is a minus cos x. Okay, so we can write here minus cos x. Okay, now listen carefully, it is a 0 to pi by 2, you can write only the limit for this integral. Okay, this x is outside the integral, but this x is outside the integral by the formula for the u into v. This x is not outside the integral. Okay, integral it is x into sin x. This x is outside of only this integral. Okay, therefore we can take limit to including x 0 to pi by 2. Okay, here इथं फक्त तुम्हाला हे लिमिट 0 to pi by 2 या इंटिग्रल साठी दिसायले. ओके, हे x या इंटिग्रलच्या बाहेर आहे, पण हे लिमिट जे काही आहे या पूर्ण इंटिग्रलला आहे. ओके, हे x इंटिग्रलच्या बाहेर नाही. ओके, हे फक्त काय फॉर्म्युल्यामुळे या इंटिग्रेशनच्या बाहेर आले. कोणत्या फॉर्म्युल्यामुळे? तर यू इंटू व्हीच्या, यू इंटू इंटिग्रल ऑफ व्ही. ओके, पण इंटिग्रेशन कशाचं आहे? यू इंटू व्ही, म्हणजे या एक्सला सोडून नाही द्यायचं. नाही तर काय होतं, एखाद्या वेळेस तुम्ही फक्त लिमिट यालाच लिहिलेलं आहे, इथून ब्रॅकेट करून टाकता हे एक्स ॲज इट इज, मग लास्टपर्यंत एक्स ॲज इट इजच राहणार व्हेरिएबल. मग आपला ॲन्सर कॉन्स्टंट येणारच नाही, मग डेफिनेट इंटिग्रल येणारच नाही. ओके, त्याच्यामुळे हे लक्षात राहू द्या. देन आता तुम्ही इथं लिमिट नाही लिहिले तरी चालतात. ओके, डायरेक्ट लास्ट स्टेपलाच लिमिट लिहा. ओके, म्हणजे कन्फ्युजनच होणार नाही. इथं लिमिट लिहायचंच नाही, डायरेक्ट इंटिग्रल काढणं झाल्याच्या नंतरच तुम्ही लिमिट लिहिलं तरी चालते. ओके, देन मायनस इंटिग्रल ऑफ 0 to π/2. Derivative, it is 1, it is minus cos x dx. Okay, and then minus x cos x, limit 0 to π/2, minus minus plus, and integral of cos x, it is sin x, and limit 0 to π/2. Now put the limit here, upper limit minus lower limit. See carefully the first bracket, minus π/2 into cos π/2. Okay, then minus 0 into cos 0. Okay, it is only this. First upper limit minus lower limit, plus again here same, upper limit minus lower limit. Now here cos 90 it is a 0, so it is a first term will be 0. Then this 0 into cos 0 it is 1, but it is 0 into, again it is a 0. Okay, it is first. Now plus sin π/2 it is 1 minus 0, and then last answer it is 1. See carefully this. Okay, here लिमिट तुम्ही इथं सेपरेट न ठेवता एकदा इंटिग्रल काढून घ्या आणि एकदाच लिमिट ठेवा. म्हणजे हे दोनदा जे आपण अप्पर लिमिट मायनस लोअर लिमिट दोनदा लिहिले ते लिहायची गरज नाही, तुम्ही एकदाच लिहिलं तरी चालतंय. डायरेक्ट इंटिग्रेशन काढा. ओके, हिअर लास्ट आन्सर काय 1. ओके, लिमिट लिहूच नका. is equal to, it is minus x into cos x, minus minus plus sin x, and now हे झालं complete integration, limit 0 to π/2. नाव आता या सगळ्याच्या ह्याच्यात एकदा अप्पर लिमिट ठेवा आणि नंतर एकदा मायनस लोअर लिमिट, पुन्हा आन्सर हेच येणार. ओके, नाव फर्स्ट वी पुट द अप्पर लिमिट, दॅट इज minus π/2 into cos π/2 प्लस साइन π/2. ओके, हे झालं तुमचं अप्पर लिमिट. मायनस लोअर लिमिट, मायनस 0 इंटू कॉस 0 प्लस साइन 0, 0 0 0, and then it is this term will be 0. Okay, plus 1, then plus 0 minus 0, and then last answer it is 1. Okay, only for the u into v. Okay, first find the integral and then put the limit, that is a 0 to π/2. It is 0 to π/2. Okay, now we see the next example. Example number 14. Integral 0 to 1 x into tan inverse x. Again here u into v, 0 to 1. Now x into tan inverse x dx, but here it is algebraic and it is inverse trigonometric function. So first function is the inverse trigonometric function, that is tan inverse x into x dx. and now here we apply the u into v. Okay, see carefully this. U into integral of phi minus integral of derivative of u into integral of phi. Okay, here we can write limit after the complete the finding the integral of this term. Now it is a tan inverse x into the integral of x, it is a x square by 2 minus integral of derivative of this tan inverse x 1 upon 1 plus x square and into x square by 2 dx. Then it is x square by 2 tan inverse x minus this 1 by 2, we can take the outside the integral and into here x square upon 1 plus x square dx. Now again finding the integral of this term, here it is x square upon 1 plus x square, that means the degree of polynomial in numerator and degree of polynomial in denominator is same, so we adjust denominator in the numerator. Then x square by 2 tan inverse x minus 1 by 2 into integral of 1 plus x square, but in the numerator there is only x square, so 1 get cancelled. For this you can write minus 1. Okay. Now this term you can write here x square upon 2 into tan inverse x minus 1 by 2 into, okay, here integral of 1 minus 1 by x square, 1 by 1 plus x square. Okay, see carefully this. It is 1 plus x square upon 1 plus x square, it is 1, and minus 1 upon 1 plus x square. So we can write it is 1 minus 1 by x square. And now integral is, it is x square by 2 tan inverse x minus 1 by 2 into the integral of 1, it is x, and minus 1 upon 1 plus x square, it is tan inverse x. Okay, here it is an integral, but it is a definite integral. Here it is a limit, so we can put the limit, it is a 0 to 1 for all the term. Okay, then first we can write the upper limit, then minus lower limit. 1 square by 2 into tan inverse of 1 minus 1 by 2 into 1 minus tan inverse of 1, it is the upper limit, minus 0 square upon 2 into tan inverse of 0 minus 1 by 2 into 0 minus tan inverse 0. It is a lower limit, upper limit minus lower limit. Now we take the calculation. 1 by 2 tan inverse of 1, it is a pi by 4. It is 1 by 2 and it is pi by 4, minus 1 by 2 into this 1 minus tan inverse of 1, it is a pi by 4. Okay, now minus this term will be 0, then minus 1 by 2 into 0 minus 0, that means again it is 0. Now remaining terms are only this. Then it is 1 by 2 into pi by 4 minus 1 by 2 into this, then it is a pi by 8 minus 1 by 2 and plus again pi by 8 minus 1 by 2 minus 1 by pi by 8 plus pi by 8, that is 2 pi by 8, and 2 pi by 8 means pi by 4, and pi by 4 minus 1 by 2, it is the last answer. Pi by 8 plus pi by 8, it is a pi by 4, it is minus 1 by 2. Pi by 4 minus 1 by 2, it is the last answer of this problem. Okay, carefully pa. Now next, Example number 15. Integration 0 to infinity x into e to the power minus x dx. Again it is u into v. Zero to infinity x into e to the power minus x dx. Now see carefully here. It is algebraic and it is exponential. In the integration by parts, exponential. It is a last function. It is algebraic and it is exponential, that is e to the power minus x. So here we will directly apply u into v. First find the integral and then put the limit. Here u into integral of v minus integral of derivative of u into integral of v dx. Now here it is x into integral of e raised to minus x. It is e raised to minus x upon minus 1. E raised to minus x. It is the integral of e raised to minus x minus integral of 1 into e raised to minus x upon minus 1 dx. It is 1 and it is e raised to minus x upon 1. Then minus x into e raised to minus x, this term, this minus minus plus into integral of e raised to minus x dx. Now we find this integral. Minus x into e raised to minus x plus e raised to minus x upon minus 1. Okay, it is a complete integral. Now here the limit 0 to infinity. Okay, limit for all the integral, it is a 0 to infinity. First we can take this minus e raised to minus x common. Then we get here it is a minus x and here it is a minus 1. And limit it is a 0 to infinity. E raised to minus x, it is e raised to minus x. E raised to minus x. Now we can put the upper limit minus lower limit. First we put the infinity, that is e raised to minus infinity into minus infinity minus 1. It is upper limit minus lower limit e raised to minus 0 into minus 0 minus 1. Okay, carefully calculation पहा. e raised to minus infinity या e raised to minus infinity ला या फॉर्म मध्ये लिहिता येते 1 upon e raised to infinity. Okay, 1 upon e raised to infinity minus here e to the power 0, it is 1 upon e to the power 0 or minus 0, it is 1, and here it is a minus 1, 0 minus 1. Now e to the power infinity, it is indeterminate, that is infinity, but it is a 1 by infinity, and 1 by infinity it is a 0. So first term will be 0 and it is a 1, and therefore it is 1. Here 1 upon e to the power infinity, it is 1 by infinity, and 1 by infinity is 0. Okay. Here 0 into this term, it is a 0, it is minus 1, minus 1, it is 1, and then it is plus 1. It is the last answer. Okay, see carefully, check the calculation.